Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
And we're back. Thanks for joining me for another episode of the Reliability Matters podcast. I'm so glad you're here. We've talked about many subject matters on this show over the last coming up on 100 episodes, and we have not covered this one particular subject, and that's the subject of training. And maybe if we talk more about training, we won't have to talk more about the defects that we spend a lot of time talking about. But it's just kind of the circle of life. People make mistakes. People learn to avoid the mistakes, and then they make mistakes again, and so it goes. My guest today is my friend and colleague Bob Doetzer, president of Circuit Technology Training Incorporated, or CTTI for short. CTTI they offer training. Let's try and get this right. They offer training in all Ipc assembly specifications, as well as CTI, Weller, ESD, Lean Six Sigma, SMT Boot Camp, and custom courses tailored to their customers' requirements. In addition to ongoing process and Ipc support after training, they offer PCB assembly and process engineering support for companies like Air Vac, Juki, or products such as Air Vac, Juki, Weller, YesTech, and Heller, among others. They have 6 state-of-the-art training centers located kind of around the world. They have one in Costa Rica and one in Melbourne, Florida, Baltimore, Maryland, Raleigh, North Carolina, Manassas, Virginia, and Rock Hill, South Carolina. So without any further ado, let me bring in my friend and colleague. We've known each other for a long time, Bob Doetzer. Hi, Bob.
Yes. Hey, Mike.
Thanks for being volunteered. Voluntold, as some people call it. Thanks for being on the show.
Yeah, absolutely. Pleasure to do it, and thanks for having me.
Yeah, of course. So you and I have worked together for many, many years as a principal manufacturer's rep relationship, in that type of relationship. You've represented our products for a lot of years. And at some point in your manufacturer's rep journey, you started a training center, a training facility, and offered training services. How long ago did you start Circuit Technology and for training purposes? And what got you into that? I'm assuming you were a sales rep first. Is that right?
Correct. Yes.
Right. And then you fell into this, or you fell into it as if it was handed to you, right? Tell me about that journey.
Some good or bad luck, I got into it.
That's right. Yes,
in 1994, I started Circuit Technology as a manufacturer's rep organization, and we represented companies such as Aqueous Technology. And roughly 4 or 5 years later, in the late 90s, obviously it was a totally different world back then in the U.S. Electronic assembly world, and things were booming. I saw a real opportunity for companies were expanding so fast, and they were throwing people at problems that they were having that had no real clue of what they were doing. About this time is when IPC was really getting its traction for its assembly specs. They've been around for a long time before that, but their assembly certifications and specifications were really getting traction. So I saw it as a real opportunity and a need in the market, and also a way to differentiate myself from other people, call it peddling equipment. So I wanted to not only represent the equipment, but represent the technology, the training, and as you say, reliability matters, and it makes a difference when people are trained. So the whole goal was not just here's a piece of equipment to solve your problem, but here's a piece of equipment and the process training to solve your problem.
Yeah,
and the two married very well.
Yeah, we our company we believe heavily in education, and because educated people make educated choices, and I guess well-trained technicians know how to handle their equipment, right? And
exactly.
It actually, I would think, in many cases, at least from an equipment standpoint, it kind of pays for itself, because you're either going to pay my team to go out and fix a problem, or pay your team to avoid the problem. So it's
exactly
either way. Yeah. I mean, money goes out the door, might as well keep your team smarter, right? Because that keeps paying over and over again.
Exactly. And the essence of training is that it makes money for the customer that got the training done.
Well, that's a perfect segue to my next question. Your company states that your mission is to improve your customers' PCB performance or processes and increase their bottom line. So, clearly we talked about one example of how training can increase a bottom line. Maybe there's less machine repairs, maybe they understand how to operate it. But what are some of the other examples of an investment in training going right to the customer's bottom line?
Sure. We've got tons of case studies, I guess you'd call it, or just follow-up from customers that have said, hey, I was a little skeptical of this at first, or maybe we were getting this training because we were required to. Particular military contractor in North Carolina comes to mind, where they originally had just done this because their military contract said they had to. They, after the training, quickly found that, hey, we really do things better now. We don't create as many defects as we used to. We're more efficient. We get more product out the door with the same number of people. And so that led to them getting more training and having us come in on a yearly basis. Even though IPC only requires every 2 years to be certified, they bring us in every year because they have found that it pays for itself many times over. There are many other customers as well. It really started with the OEMs. There's another medical device manufacturer that we work with that a couple of weeks after doing training, the guys sent me an email and said, hey, I just want to tell you, our scrap rate has gone down significantly since you've done the training. And those are the things we love to see and hear. Now even contract manufacturers have really embraced it. In today's world, it's hard to find good people. Everybody's struggling to keep up with work. So sharpening your axe, as it was, is a good idea. Getting your employees that you have better trained, more efficient, so that you do it right the first time and don't have as many defects. That's the whole goal, and we see that over and over again.
You talk about IPC requiring training, recertification every 2 years. I was when I was in elementary school 1,000 years ago. I was in the one of the first schools in the United States to go year round. The traditional, you go to school for 9 months and take 3 months off during the summer. And we were the first school in the country, as I understood it, to go year round. It was approximately 10 weeks on, 3 weeks off, 10 weeks on, 3 weeks off. And you had kind of a quarter system. And one of the outcomes of that, which has now made its way to many schools throughout the U.S., not all, but many, was that the amount of retention of everything you learned stays higher if you don't have a 3-month break during the summer. And that the first couple of weeks back at school in the fall from a 3-month traditional summer break was spent kind of relearning, bringing the kids up to speed, where they left off 3 months earlier. And when they had shorter breaks, they didn't have to spend anywhere near as much time, catching up. And I would assume that seems logical, right? So I would assume that the same goes for training, even though IPC might require it every 2 years. It's probably not a bad idea to have it more often than that. That way, a lot of that, you improve retention of all of that information, because human nature is it's pretty consistent. We tend to, if we're not required to do things a certain way, we tend to kind of lower our guard a little bit and take the easy path and not necessarily do things the way they're supposed to be done. But if we are trained regularly with some, more frequent cadence, I think that probably also pays for itself.
Absolutely. Yeah.
We're in a situation now where we're starting to see some young blood come into our industry finally. And if someone graduates from a university with a electrical engineer degree, just for example, I'm assuming they're quite prolific in their understanding of how electrons work. They kind of know the physics of electronics. They probably know, how to read a resistor, the bands on color bands on a resistor, things like that. But they may or may not be familiar with the kind of the more subtle details of our industry. How much pressure to put on a squeegee, how to use a thermal profiler, what IPC standards are, what IPC is in general. I'm not sure if young people graduate university with that detail of information. What's the answer to that? When young adults graduate with a bachelor's degree, for example, in electrical engineering, are they familiar at all with IPC and their standards and the details of the standards, or is that left up to the industry at that point? Does the industry accept the baton at that point?
Yeah, for the most part, it really is left up to industry, and it's an interesting question because I have 4 kids and they've all graduated from college and they all think they know everything, and they really don't know much. Same thing, these guys that graduate and gals that graduate with a EE degree, they're obviously very intelligent. That is a significant accomplishment. But if you threw them out in front of an SMT line or a bone pile of defective circuit boards and some rework equipment and told them to fix it or assemble the board on the SMT line, they would have no idea. And that's not a fault of theirs. The university just doesn't teach it. Ironically, there are many VOTEC schools that are now teaching it. And the community college system has really embraced it. Starting to see a few universities embrace this, but it's very, very few. So someone that graduates from college is obviously very intelligent. They can handle the material of the IPC training without question. They're smart enough, but it's something that they've never done before. And it is funny because we are getting more young people, which is great to see, obviously, because it's been a while since we've had young people in this industry. But we're getting more young people, and they really don't know. I mean, to say that they don't know which end of the soldering iron to pick up might be a little bit of an exaggeration, but it's not too far off.
The hot end, Bob. I haven't been through your training, but don't pick up the hot end, right?
You only do it once.
You only do it once. That's right, and you have proof. That's my training certificate. The scar on my hand, right?
Yeah, I got a few scars. Yeah,
that's good.
So we are seeing that, and it's a very, very much an eye opener for them to go through these training classes.
So who should receive training? There are line operators, there are technicians, there are QA people, and production managers, things like that. Who are the most common? What is the most common level within a contract manufacturer or an OEM?
Sure.
To receive training?
So all of the above, really. So the IPC certifications have 3 different levels: CIS, which is Certified IPC Specialist; CIT, which is Certified IPC Trainer; and CSE, which is kind of in the middle of the two, and that's the newest one, and that's Certified Standards Expert. It's basically a trainer that doesn't train. IPC wants people that are certified as a trainer to actually train. They don't want trainers, non-training trainers, if that makes sense. So in the CIS level, think of operator level. So you think of, your typical operator on the line, technician, repair operator, soldering, touch-up, QA and line inspector, that kind of thing. Then when you get into the CIT and CSE level, that's more of the manufacturing engineers. In a small contract manufacturer, it could be the owner of the company a lot of times. So not as typical, of course, but process engineer, manufacturing engineer, quality engineer, those are typically the level and the job descriptions of the people getting their CIT or CSE certifications.
Interesting. Is it just as important for an OEM and a CM to embrace these standards? Let me give you some context on that question. Several years ago, I was hired as an expert witness in a civil litigation matter between an OEM and a CM, and I was representing the CM. And the OEM prescribed a statement of work that was quite faulty, and the products failed. There was a huge recall, and the OEM blamed the CM. And when the CM produced the statement of work and copies of all the correspondence and emails and change orders, they basically had them build boards without any regard for best practice, certainly without any regard for standards. In fact, they didn't even know what IPC standards were, the OEM. And the contract manufacturer, their biggest mistake, frankly, was doing exactly what the customer ordered. They gave them exactly what they want because the customer's always right. And they thought they had a get out of jail free card because they had this statement of work that said, do it this way. And of course they got sued. And one of the things they were sued for was you're the expert. You should have told us that we were doing it wrong, that we told you to do it wrong. Instead, you did what we asked. And there's probably some validity to that, at least practical validity, if not legal validity to that argument. But in this case, it would have been really good for the OEM to know what the IPC standards were, because they would have incorporated those or at least cited those in their statement of work. And it really would have been good that the CM had all that knowledge. Now, they may have, but they just chose not to use it. But maybe if they had better knowledge of it, they would know that it's not an option not to use it, not to implement it. So what, from an OEM to a CM, how important is it for them to embrace IPC standards in the general context?
Yeah. So at first, the OEMs were the ones that originally adopted and embraced the IPC standards. And I guess that makes sense. But really today, it's more important for the CMs to embrace the IPC standards for a couple reasons. Your situation of the expert witness is a classic example of that. Ironically, I was an expert witness a few years ago in a case. I was actually representing the OEM. Their work instructions were pretty clear in that they called out the IPC 610 and J standard, and the CM did not build to those standards because they just didn't understand them. It wasn't a U.S. contract manufacturer. It was a foreign contract manufacturer, and they just really didn't understand them, and that was pretty obvious, and they lost the suit. Now, there's a whole lot of reasons other than just being sued to understand the IPC standards and embrace the IPC standards. They work. I mean, these are a compilation of thousands, sometimes hundreds of thousands of hours of research by big name companies that we've all heard of and really smart people. So take advantage of the brain damage that these guys have suffered over the years and learn from them. And you will make better product. You will make it more efficiently. You will make less defects. You'll have higher quality with longer term reliability if you follow the IPC specs. It's tried and true. It's bulletproof at this point. The other issue is not related to reliability at all. If I'm a contract manufacturer and I'm trying to get business from OEMs, I want to show that quality is a very important piece of what we do. And it's such an important piece that I have all these certificates on the wall of all my people. Anybody that touches your circuit board will be trained in that specific discipline of IPC that it is required. So I'm not just saying we make good stuff, but I'm proving it through that. So there's a marketing aspect to it as well. And I think it's actually kind of flip-flopped, and that it's more important for the CM at this point because of what you said before. Your OEM, the example you used, didn't really understand. And that's the case a lot of times. Most of these OEMs, they've lost that tribal knowledge of understanding how to build a circuit board. So they're relying on the contract manufacturer to be the expert. And then the contract manufacturer can then rely on again, hundreds of thousands of hours of research that's gone into the IPC standards. So it is by far the path of least resistance to building good circuit boards.
Yeah, I would think to your point, it's a huge selling point for a contract manufacturer to have their employees certified in various levels of standards. If I were looking at two contract manufacturers as an OEM, one didn't have trained technicians and one did, clearly, all things being equal, I would certainly gravitate toward the one that that did have the training, and maybe even pay a little extra for that because
Right.
things might get right the first time. And
Yeah, it's one piece of the puzzle. What a contract manufacturer customer line that comes to mind, as soon as you walk in the front door, you walk down the hallway to the production area. That's where he's hung 50, 60 IPC certifications of his employees. So as soon as the customer walks in, it's not in their face, but it's off to the right as they walk by, and it's kind of like a wall of fame, if you will, as they walk down the hallway. And I thought that was brilliant. I mean, that was a great thing to do. He doesn't have to say anything about it. They always ask. They see the certificates and they always ask.
Yeah, that's
so
great.
It's a perfect segue for them.
And not only is it an investment in their employees, it really is an investment in the company. It's an investment in the industry. It's more than just having an operator know what end of the soldering iron to pick up. There's certainly a practical application for that, but it also, I think, sends a message that they care about the product they're producing, and and they're doing something over and above what is strictly required. I mean, there's nothing stopping me as an OEM or a contract manufacturer from building a board knowing nothing about standards and shipping it to somebody, right? I mean, I'm allowed to do that. Anyone can. But those that put the effort in, probably it probably shows throughout all areas of their company, not just that.
Exactly.
Right.
Exactly.
I live in Southern California, and we have a lot of contract manufacturers in Southern California, particularly throughout Orange County. And the majority of them are one particular ethnicity, I think Vietnamese. There's a lot of Vietnamese contract manufacturers in Southern California. And I've been in and out of these contract manufacturing places, and on the production floor, not so much management or middle management, but on the production floor, it's very difficult to find someone that completely has a good understanding of English. Their English is better than my Vietnamese, so there's no slur there at all. I mean, I respect anyone that can say hello, right? In English, because I can't even say hello in most other languages. But if someone were to want to send their employees for training and their English skills are limited, or because their English is a second language or whatever, what challenge does that present in training? And have you been able to overcome that challenge, at least partially?
Yes, at least partially, and it does present a challenge. By far, the most we see is Spanish, with Vietnamese being second. We're fortunate in that we have 5 master trainers, and we have 2 that are fluent in Spanish. Their native language was actually Spanish. So they speak very good English, but they also speak excellent Spanish. So we do classes regularly in Spanish. We can't do it in both. It just doesn't work. You can't teach in both because it essentially takes twice as long. However, if we have somebody at a company that struggles a little bit with English and they have Spanish as their native language, we can spend a little extra time with them after class, at breaks, maybe explaining some concepts that they don't quite understand. And that's worked very well. So we have those 2 things. In the case of the Vietnamese or Chinese or some of the other languages, most of the specs are available. I won't say all. Most of the specs are available in different languages. So occasionally we'll have a class for a customer and they've got 10 people, and 2 of them are Vietnamese, and they can understand English, but they struggle a little bit with it. And so in those cases, we'll get them an English spec and a Vietnamese spec.
Okay, so they can cross-reference it in real time.
Exactly,
right? Okay.
In real time, yeah.
So
there's some things that we can do to overcome that, but it's definitely a challenge, especially with the Spanish. But we do have the 2 fluent Spanish instructors, which significantly helps. So, and then we have the training center in Costa Rica. Those classes are all in Spanish.
Right.
So.
Right. Yeah, that's good. I would imagine. Do customers in the U.S. send their people to Costa Rica because of that? Is that because they'll know they'll be totally immersed in a native language, or as opposed to someone speaking it here, someone speaking Spanish here? I mean, do they choose Costa Rica as a destination just so that it's an organic Spanish, or no?
So
or is that more of a vacation?
Yeah, not that I know of, but we have had a bunch of people say, "Oh, I want to go to Costa Rica. That's where I
Yeah.
want to take my training." And then we say, "Well, great, but you have to speak Spanish." And then oh, geez,
Well,
there goes my
you
vacation.
need to move your training center to Cancun.
Yeah,
I will learn Spanish just to take a training course there. There you
right.
go.
Maybe we should open in Grand Cayman or something English speaking that people would want to go to.
Absolutely, that's right. You can pet the stingrays and learn how to pick up a soldering iron all at the same time.
Yeah, I'll volunteer for that training mission.
Yeah, and I'll come out just as a reporter and
Exactly.
and document the process. There we go. A business plan was developed right here on the show. What percentage of students pass and fail? Do you track that?
Actually, we don't. We probably should, because that's an interesting question. And we definitely have people that fail. There's no question about it. If I had to put a number on it, I'd say 20%. However, our instructors are really good at observing and kind of, I'll say, getting inside the student's head and noticing if they're struggling. So they notice pretty quick whether they're picking up on the concepts. Because our instructors are really good at engaging the students and getting involved in the class and asking questions, them telling stories, as well as the instructor telling stories, relating something in the IPC spec to something that they've done in the past. All of our instructors are guys that used to build boards. So they have a lot of anecdotal stories that they mix into the training class, makes it more interesting and more relevant. And then they also try to get the students to bring in their examples as well. So they are good at picking up that, hey, Mike Conrad's not doing so well. He's not really getting this concept.
Such a slacker, that guy.
So at break, they'll ask them some questions about it. After class, they'll ask them questions about it. And then they'll go through it with them. So we try to see that before the train goes off the tracks, and then help them out so that they can pass. Even with doing that, we still get, let's just say, 20% that fail. More so on the CIT and CSE level, because it's a more stringent exam than on the CIS level. But when they do fail, then we say, okay, what did you struggle with? And then we work with them to get through what they struggled with. Sometimes it's just test anxiety. We see that a lot. People have test anxiety. And then it becomes our instructors need to just talk them off the ledge and say, look, you really do understand this. Don't get tripped up by some of the language. Just don't get focused on negative things. Just work your way through the test and do it. Then there's sometimes where they just don't understand concepts and we work with them.
Right.
If it's hands-on, that's much easier. They're either making a good solder joint or they're not in the classes that require hands-on. So that is very easy for the instructor to work with them and get them to pass. So
if someone fails, do they have to take the whole course over again, or
No.
what are their options?
No. So their options are to take the test over again, or if it's hands-on, to do the hands-on kit again. There's a waiting period, but we can do that fairly quickly. And I would say of the people that fail the first time, 99% of them pass the second time because we work with them and they see what they did wrong and they kind of get it in the second time.
Well, you almost need a 20% failure rate just to validate the test, right?
Yeah.
If you had 100% success rate, then clearly it's too easy. There's less need for training. If you get a 20% fail rate, then you know that you started at a lower level than you expected, right? And there was just more for them to learn, which validates the whole concept of training.
Exactly.
We talked earlier, you kind of almost answered my next question. With IPC, J standards, for example, evolving. We had G just in 2018, and now we have H, about 2 years later, which is, I think, a pretty rapid change for for the J standard. I don't think it changes every 2 years. I think it's gone longer between changes. I could be wrong on that, but we're only up to H. So J standards have been around a long time. So how often Well, let me phrase it this way to make it a fresh question. If someone was certified to G, and then 2 years later H comes out, do they automatically need to be recertified to H, or can you get by on if you're 2 or 3 letters behind?
Yeah,
that makes sense.
So it's a great question because we get this question all the time, literally every day. So although as a training center, we'd love it if they had to recertify to H. No, just kidding. So none of the specs are rev specific. None of the certifications are rev specific. So if Mike Conrad is certified to IPC J Standard 001, nowhere on their certificate does it say rev G, H, XYZ. It doesn't say it. So you are certified to the J Standard, and your certification is good for 2 years. You do not have to recertify for 2 years. It could rev from G to H to whatever, and you still do not have to certify. You are an active J Standard recipient and valid. However, IPC is always trying to improve. They're always trying to keep up with the times. They're always trying to make things better. So in the past, where it might be 4 or 5 years before a rev change, I think that you're going to start seeing that be more 2 to 3, maybe 4 years going forward. They're trying to make it as relevant to today as possible. And again, just because you're certified under Rev G and then Rev H comes out the next day, it does not matter. You are still certified to the J Standard or whatever spec. It doesn't matter.
Well, I think what the safety mechanism in place to make sure your knowledge is not obsolete is the renewal every 2 years. I mean, you're really, even with a fast pace rev change, you're not going to be more than 1 rev out. If you're certified,
you'll never be more than 1 rev out.
Right.
Exactly.
Until they start changing them every week. Then maybe that you'll have to get more frequent certifications. But right now it's like every couple of years or longer.
Yeah.
I know that I would assume that during the pandemic, you had to switch over to some more virtual models. Obviously, you can't do a virtual, soldering exercise. You might be able to teach techniques virtually, but you can't actually do a hands-on with digital hands. What types of training courses lend themselves to virtual training versus, absolute requirement for hands-on?
Yeah, so the pandemic was a total game changer for the technical training business. It was a disaster. 2020 was a rough year. IPC previously, up until the pandemic, would not allow any training other than in person for good reason. I mean, there was the interaction with the instructor that was very important in these specs. Because of the pandemic, they now allow virtual training over Zoom, WebEx, whatever, Teams, on anything that doesn't require hands-on. So that would be IPC 600, the bare board spec, 6012, bare board spec, 610, workmanship standards for assembled boards, 620, wire, cable, wire harness assembly. All those do not require hands-on. 620 has an optional hands-on module, but it's not required. So those specs can all be done and certified online. The student doesn't have to come to a training center. And we do that all the time. That's very popular now because of the pandemic.
How many of those courses online did you offer before the pandemic? Oh, probably none, because IPC didn't allow it. Zero.
IPC didn't allow it.
And do you think after the pandemic is over, if it ever is over,
if it's over,
we went from thinking this is 3 weeks. We can shut down for 3 weeks. We'll be fine, right? And that was a year and a half ago.
Right.
But do you think after this is quote unquote over, they'll tighten it back up, or is the toothpaste out of the tube?
Yeah, I think the genie's out of the bottle. Yeah. I think it works. I mean, the long and short of it is it works. It was weird at first, maybe, but now we're all used to it. We're all used to the world of Zoom. Yeah. So, and the training just works. So my guess is that that'll stick around even after the pandemic, if it ever ends. So,
well, that's got to be really a good thing for the little silver lining in this whole crazy time for the training industry, because it really allows more companies to provide training
Absolutely.
for more employees because they don't have to give them up, right, for a
Yes.
week or a few days or a few hours. They can do it from their office, from the cubicle, from home, whatever.
Yeah. Well, so the IPC specs are still not allowed in a recorded format. I think what you're thinking of is recorded format, and we do have some.
I mean, just even doing it live. There's still, if I had 5 employees I wanted to send for training, I'm going to lose 5 employees out of my building for a
Yes.
short time because they have to go to one of your training centers formally
To the
before the
training
pandemic.
centers.
Now,
Correct.
on certain courses, they don't have to leave my building. They can
That's
be
correct.
trained through a live event, but
A live event,
virtual
yes.
live event.
Yes.
Okay, and then now you just put a new question in my head, and that is they don't allow a pre-recorded. They want the instructor and student exchange to be there. Is that the reason why they're kind of against recorded?
That's correct.
Yeah, that makes sense.
That's correct. And our instructors at first didn't like the format, but now they like it. They don't have to travel to the customer's location, for instance, or to one of our training centers. So they can do it from their home, and it gives them a little more freedom. So we've gotten better at it, and it's just the system works now. So
did IPC provide waivers when certifications were up for renewal and there were no ways to do it because of the pandemic, before virtual options? Did they allow extensions?
Yes, they allowed us as a master training center to grant extensions, and that's over now. Though they figure that there's enough good ways to get recertified, so no more extensions.
Right. Okay. So frequently in training, the trainer must deprogram old skills as much as they have to program new skills, right? You have to,
Yes.
And I don't know what's harder, teaching, undoing habits from the past or starting from scratch. I think starting from scratch is easier. I think unwinding old habits and
Absolutely
is probably harder than teaching the replacement habits. Well, let's take soldering, for example. What are some of the common methods that one must unlearn, other than which end of the soldering iron to hold? That's like an entrance exam. If you don't pass that, you don't get in the course. But
right.
what common things must they unlearn before you start teaching them how to do it right?
We see tons of bad practices, bad habits in soldering and rework. Examples: turning the temperature of their soldering iron up to 900 degrees. Well, if 700 is good, then 900 must be better, right? Another one is pressure. As if somehow, if I push this soldering tip into the circuit board harder, that the heat will transfer into the board better. That's like saying if I plug in the vacuum cleaner to the wall harder, that it'll suck better or something. I don't know. But that's one we see all the time. And obviously pressure leads to, measle boards, lifted lands, lifted pads, lots of problems. Just bad techniques with hand soldering and rework are all over the place. And you're absolutely right. Untraining is harder. Untraining the experienced one can sometimes be harder it usually is harder than the fresh one. And 2 quick stories. We had somebody recently, and this has happened many times over the 25 years, but they were not happy. They came to one of our training centers and they were not happy that they were there. I've been doing this for 20 years. I don't need this class. This is stupid. I don't know why they're making me do it. So, almost to the point of being disruptive. But actually our instructors like that, because this person at the end of the class, they said to the instructor, I got to hand it to you. I learned a lot in this class. I was a real jerk in the beginning of this class, but I learned a lot. And maybe that's an extreme example, but we see that a lot, and we hear that at the end of the class.
I'm sure more people think it than say it, right? At least at
more people
first.
think it than say it, exactly.
Right.
Another quick anecdotal story is we had, I happened to be in the office this time, and the phone rang, and it was a kid. I could tell it was a kid on the phone. And the kid's asking me all these questions about soldering and training and all this. And I'm talking to the kid. He was very polite. And then he says, can you talk to my mom now? I've never had that happen before.
That's
And that
funny.
happened just recently. And so the mom got on the phone and she said, this is my son. He's in high school and he really wants to do this. He was 15 years old. He wasn't even 16 because he couldn't drive. And he said, I don't know if he should do this. Is it all right? And I said, well, it's fine with me. I have no problem. He seemed very polite and I got no problem with it. So the kid shows up. His mom drops him off because he couldn't drive. And he attended a IPC 7711, which is rework and repair. And he just wanted to do this stuff on his own. He wanted to build stuff on his own, which is great. And he was a rock star. He had never soldered anything before. Now, granted, he doesn't have shaky hands like maybe you and I do.
Right.
A little too much coffee, maybe
Right.
too much libations the night before. But he was a rock star. Not only did his soldering just completely outshine most anything we've ever seen, he got 100 on the test. He didn't get one wrong. So, there's just a kind of a funny story about exactly what you're talking about.
And I think in most states you have to be 16 to work. So in about a year, he'll be one of your trainers.
Yeah, right.
Like a Doogie Howser in IPC training.
Exactly. You don't need high school kid. Come on.
Exactly. Yeah. I would imagine you talk about mistakes made, pushing the iron really, really hard against the board or turning up the temperature. 900 is better than 700 because 900 is a bigger number. I'd go to 2000 if the iron would go to 2000.
Right.
How many times do you feel like an art class where you're teaching solder sculpting versus soldering? I remember in the early days of learning to solder, and I never went through a training course. I just, figured it out 1,000 years ago. At some point you're just building giant, basically a big solder boulder to hold the wire down to the pad. There's no interconnect. You're just creating this kind of prison, this solder prison to hold the wire down. You could flick it off with your finger, right? It's not really attached to the board. It's just kind of stuck. But we've all done our fair share of cold solder joints and solder sculpting and trying to, fake the fillet, trying to fake the right angles by carving some of it away, and rather than letting it just flow naturally, right? We've all done that. I've certainly done that, and been amazed when the wire falls off. Yeah, with the solder blob attached to it.
Right. Yeah, you weren't thinking about the intermetallic bond back then.
No, I just wanted to make sure it stuck. Right. It might as well have been conductive superglue. That would have. It kind of looked like that.
Hot melt glue.
So there's two types of courses your company teaches. One are IPC training courses, and then you have a bunch of other courses, SMT Rework, Combo Tech, Advanced SMT and Through-Hole, SMT Boot Camp, Lead-Free Soldering, and some others. What are the differences between those courses and the IPC training courses?
Yeah, the main difference is that those don't carry an IPC certification. So it's not an industry-wide, industry-recognized certification. They're typically for things that either the IPC doesn't specifically address, like SMT Boot Camp or BGA Rework or Advanced SMT, which is all very fine pitch devices. The lead-free rework, that was really popular back in, 2006 when lead-free became prevalent. Not so much anymore, but lead-free solders reacted, soldered, totally different than tin lead. So, it needed a specific course. So they're generally things that are targeted, laser focused on a specific issue that a company is having. Through-hole rework only, SMT rework, BGA rework, SMT Boot Camp. And all these things are in compliance with IPC standards, obviously, but they're not the IPC curriculum, and they don't give an IPC certification. It's for the customer that doesn't need that industry-wide recognition, but they need a solution to their specific problem. This is my headache. I need a solution, and we laser focus on that.
What's the most popular IPC course that you offer?
That's a loaded question in that it changes, and I have no idea why. We'll go through stretches where 610 is the most popular class, and we can't put them on fast enough. And then it'll kind of wane out, and J standard is the most popular. I'd say J Standard, to answer your question, I'd say J Standard over the years has been the most popular class. It's the most broad-based, it's the most all-encompassing. It involves a little bit of 610, it involves a little bit of 7711, a little bit of 620, a little bit of process. So it's got everything in it. So I would say the J Standard is the most popular class. And then when customers want to focus on some other specific thing, rework, maybe they got a bone pile of boards that they need to figure out. This thing, pile of boards sitting there costing me money. How do I turn that into cash? So they'll send a couple people to the Ipc 77 rework and repair class. So I would say J Standard to answer your question. That was a long answer to a simple question.
No. It's good to find out why.
Yeah.
From a layman standpoint, what are the differences between not down the rabbit hole differences, but just from a surface level difference? I hear 610 and J standards thrown around a lot, and almost interchangeably. What's the primary difference between the J standard and 610? Because they have a lot of commonality.
They do. They have a lot of commonality. In fact, one of the modules of J standard is inspection. So it's call it a Clip Notes version maybe of 610. That's an oversimplification, but it does hit the highlights of 610, and it does the inspection criterion for the things that you worked on in the J standard. So the 610 is just focused on inspection, workmanship standards, inspection criterion of assembled circuit boards. The J standard is going to talk more about the process and how you get to a good solder joint, a target solder joint per Ipc 610. It will also incorporate some of the 610 concepts in the inspection module, but it more focuses on how do you get to that point. Does that make sense?
Yeah, perfect sense. Your company, you talk about you have master trainers. I think you have 4 master trainers, if that's still accurate. What's the difference between an IPC trainer and a master trainer? I for some reason I just kind of equate it to a black belt, in karate or some martial art. What is it? What are the requirements to be a master trainer, and what's the difference between trainers and master trainers?
Yeah, so there are additional requirements of a master trainer above and beyond the CIT or Certified IPC Trainer. A CIT takes the CIT class, they pass all the criterion, and they're a CIT, and that gives them the credentials to then certify people within your organization to the CIS level. So if you wanted to become a CIT in 610 or J Standard, you could then train all the people at Aqueous Technology to the CIS level of those specs. To train somebody to the CIT level, you have to have a higher certification, and that's the MIT, or Master IPC Trainer. 4 of our trainers are MITs, and actually we just hired a new trainer, a 5th trainer. He's not an MIT yet because it's going to take him time to earn the MIT title. So an MIT can train CITs and CSEs, whereas a CIT can only train CIS people. The MIT has to train a bunch of CISs before becoming an MIT. They also are required to do, there's a point system for basically extended learning, so they have to demonstrate going to other certifications and getting other continuous education, basically. And then they get a points system, and then that qualifies them for the MIT. So, for instance, our new instructor, he's been a CIT in the past, but his CITs are not current. So he will have to take all of the CIT classes and, of course, pass them. And then he'll have to train CIS classes, and then he'll have to get those continuing education credits to become an MIT. It's going to take him about a year. So, okay.
And
maybe a little bit less.
Who tests the master trainer?
Another master trainer. So there's no higher level than that.
I would think it would just keep going up and up and up, right?
Yeah.
The master trainer.
Yeah, the Pope can give him that. He's the only one.
So at some point, you have to kiss a ring. At some point.
Yes, at some point,
Yes,
we always have to kiss a ring.
Exactly. An IPC ring or something.
Yeah.
The non-IPC training courses, are they taught by the same level of there's probably not a requirement to teach a soldering course. It's not an IPC soldering course, for example, or Combo Tech, or SMT Rework, a boot camp. You probably don't, I'm guessing there's not a requirement to have a IPC certified trainer
Correct.
train that, because there's no certificate that comes with it. But I would imagine they're still taught by the same people, or do you have
Yes.
a different set of instructors for those?
No, we have our 5 instructors are all very lucky to have guys and one lady with an extreme broad breadth of experience in circuit board assembly and training. So it's all the same instructors, but there is no requirement for our SMT Boot Camp class for that instructor to be an MIT. So, for instance, our new instructor, who's been a manufacturing engineer for roughly 25 years, he could actually teach that SMT Boot Camp class very well, because that's what he's done for 25 years. But he's not an MIT yet. He'll be an MIT. It's just going to take him some time.
Right. But he doesn't have to be for those types of courses. I love the word boot camp. Whenever I see a training course that says boot camp, I always get excited, because it usually covers an awful lot of, it's a wide course rather than it's more horizontal than vertical, right?
Exactly.
And I like the horizontal courses. I always get frustrated when we talk about one tiny little part of the assembly process, because everything has a context to it. And
exactly.
to me, I get more out of it when it's got a not just depth, but breadth, right, of information. So the boot camp sounds exciting. Tell me about what types of, we don't have time to go into every class that you have, but just from a 30,000 foot view, what types of SMT knowledge will someone get in a boot camp scenario?
Sure. So our typical SMT boot camp, and this is a perfect example of the horizontal nature of the training that you're referring to. So we look at every piece of the SMT assembly equipment. So printer, placement, reflow, inspection, and also wave solder, even though it's not generally SMT, it could be cleaning, test. We look at all of those pieces of the puzzle, and we look only at the process. So for instance, the printer, we talk about all the parameters in the printer, the stencil aperture, stencil design, the squeegee pressure, the wiping of the stencil, everything that can be a factor in the overall quality of the product down the line. We talk about that. And then we talk about the defects. What defects typically come out of the stencil? And then how do you fix that? So you got bridging of the solder paste. How do you fix that? Well, you go back and, is your stencil clogged? Have you done a wipe? So it has nothing to do with the specific piece of equipment. So it's completely gender neutral, if you will. So it doesn't matter whose brand printer it is. It's just process of the printer. And then the placement machine. What defects can typically be generated at the placement machine? How do you fix that? So that's a 5-day class. It's very comprehensive. They'll do some hands-on, because we'll do profiling. They will actually do some soldering and some rework. They'll do a lot of inspecting of boards. So it's looking at the whole piece of the process, and not just saying, oh, if I've got a defect out of the oven, then it must be from the oven. Well, not necessarily. It could have generated at the printer. And in fact, it probably did. Does that make sense?
Yeah, thank you. It makes perfect sense.
Yeah.
In the intro, I talked about some of the things that you train to, and you train on assembly specifications, such as, and you mentioned Weller, and there's some Heller, YesTech, Juki, Air Vac. You mentioned engineering support for these types of products. Are there specific companies, YesTech, Weller, Juki, Air Vac, Heller, example, that you train do you train people to operate those particular pieces of equipment specifically, or tell me why there are brand names in here? Is that because you're working with that manufacturer to provide training for them?
Yeah.
And let's take Heller, for example, Heller Ovens. Do you work with Heller? Do they have to train you to train the customer? Do you have to go through some kind of learning process specific to that brand of equipment?
Yeah. So our affiliations with these companies are because we represent them in the other side of the business.
Mm-hmm.
So we have access to training from them and other documentation and things. We are still not the best resource for training on how to operate that piece of equipment.
Okay.
That's always the manufacturer.
Yeah.
But if a customer wants specific process training, let's take Heller, because you mentioned that. If they want training on profiling, and we know the Heller oven very well, or YesTech AOI, if they want process training on AOI, not programming the machine or specifically which buttons to push, we've had our guys go through some training, so they know that to some extent, but they still don't know it like the field service engineers from those specific companies. Those are always the best resource for specific equipment training. We are always going to focus on the process. However, we are more familiar with Air Vac rework machines or Weller rework machines or Heller ovens or YesTech AOI or Dage X-ray, that kind of thing.
Yeah.
Aqueous Technologies.
Right. Now that makes perfect sense. It's not a certified course. They're not getting a certificate from the manufacturer that Bob taught them how to turn it on and how not to run the conveyor backwards and what end of the iron to pick up. You don't get a certificate for that.
Yeah.
A little less formal, more practical training.
Exactly. More practical.
That makes sense. So finally, as we wrap up, what's the future of training? Get out your crystal ball. I know we made a lot of progress in the last couple of years. We went from it has to be live to some of it at least can be virtual. I think that's a huge milestone.
Yes,
and that will open up training to more and more people for reasons we talked about earlier. Do you see any other potential milestones that we're going to cross in training? Do you see new standards that are maybe IPC's working on that haven't been released yet that will be not a revision but something new that we'll have to train to? What's your outlook on training?
So we've definitely gone through a transition period these last year and a half, 2 years. It's been interesting. I actually think we're in a better place today than we were 2 years ago because of this hybrid model of doing things online as well as in person, and doing as much online as possible just allows better access for companies to get training. I also think that companies are, and this was a trend before the pandemic, but just the trend was to realize the benefit of training. The companies that get training, they realize the benefit of training. So training in general, I think, is becoming more and more important. A, because of that, and B, because of the fact that, like you said before, so much of the tribal knowledge is aging out of our industry. And then you have all these, this younger generation coming in, and they just don't have the tribal knowledge of building a circuit board. So, and you just can't get that in the EE program at, MIT, whatever, really good school. There's a lot of things that they do get, obviously, but they're not getting that circuit board assembly experience. So I think the future is very good for our training. I think the hybrid model makes it more accessible to everybody. I think there will continue to be some evolution in that hybrid model. I'd like to see some more, the hands-on stuff go to hybrid. I realize it can't all go there, but I think the more that it can, the better. We'll see how that evolves. IPC is always coming out with new specs, certainly new revs, but like, for instance, they came out with the Automotive addendum recently to the IPC 610 and J standard. It's not a new spec per se, it's an addendum to the 610 and the J standard specifically for the automotive industry, addressing the specific challenges to the automotive industry, which are unique. The, under hood electronics, it's a very unique environment. So several years ago, they came out with a space addendum to J standard and 620, same kind of thing. So I think you'll definitely see those type of new specs come out as well, and customers embracing training more and more, as they have been, as that trend has been for the last really 20 years.
Muted myself. I would think that there would be, if not already, a pretty substantial growing market in automotive, because automotive for so many years has marched to the beat of their own drummer. And
yes,
one of the differences, and I've said this on the show before, between a traditional automotive manufacturer, GM or Daimler or Volvo or whoever, Ford, is, and the difference between them and companies like Tesla is a tech company building cars, and the other companies are car companies incorporating tech. And
right. Exactly.
And tech is, I don't want to say new to them, but it's not necessarily their wheelhouse. They're using companies like Continental and Bosch and others to produce that tech for them, and it always seems like an add-on versus something that's truly just designed into the product. And I could be wrong on that, but that's the impression I have. And I think the reason why Tesla's incorporated electronics far more, maybe even more reliably, I could be wrong on that, than traditional car companies, is the fact that they started as a tech business. And now maybe their mechanics aren't as good as the mechanical side of their cars may not be as good as the traditional car companies, because that's their wheelhouse, right? They know how to put engines in small spaces and build transmissions and drivetrains and all that stuff. So it just seems like there could be a really good opportunity as the automotive industry recognizes that just because boards go into a car doesn't make them special, doesn't make them unique. They're still playing by the same rules, of harsh environments and ECM and all the other, the same solderability requirements, if not more, are required because of the harsh environment nature of automobile electronics. So maybe that will lead itself to more and more people within that space becoming more educated and more and more aware and certified to IPC standards. It just doesn't seem to make a lot of sense to reinvent the wheel. Pardon the pun, since we're talking about the automotive industry, but it because IPC's already been there. We've already figured out how to build boards and what makes them fail and what makes them more reliable. And I think the auto industry is slowly kind of coming over to this side of the business. I think
they absolutely are, and you're absolutely right. I mean, a car is less of a mechanical device than a mobile device, like your cell phone today. So why wouldn't they learn from all that IPC has done over the last 50, 60 years? So it just makes perfect sense.
I remember several years ago I was at a conference and I think I was on the stage with them, or it was a panel, and someone from the automotive industry was on the panel, and we were talking about cleaning, and he said rather proudly, like, we're the automotive industry. We use no clean. We don't clean. We will never clean. It was just this pronouncement. It was just dig the stake in the ground and fall on your sword there. And now they clean. Not everything. They clean what has to be cleaned, but now they have to. There are certain things that just have to be cleaned, or bad things happen. So it's just interesting to see this kind of slow progression between we do it this way because this is who we are versus versus kind of an openness to learn. Like, well, how does the rest of the world do it? What are we doing differently? Should we be doing it differently? Should we adopt some of the standards?
What can we learn from all these other companies doing this? Yeah.
Right.
And fortunately, I think that mentality is slowly, I don't know if it's aging out or just becoming more aware that there is a lot of knowledge out there, and that we shouldn't just say, this is who we are, this is the way we've done it for the last 100 years, so that's why we're going to do it this way the next 100 years.
Right.
That's
I think I think the aging out is probably a big part of it, and and the necessity. I mean, there are certain things that they just can't do the way they used to anymore because the rules have changed. Components have become smaller and denser, and miniaturization and harsh environment and higher reliability expectations. All that has just created this perfect storm of factors that just make the rules more important. Right. The tolerances have all gone away. We no longer have plus or minus anymore. We build it right or it fails. There's just no middle ground.
Right. And in fairness, if that was a 60-year-old guy in an automotive company, when he started in the business, the only circuit board in the car was the radio. So
that's right. Exactly.
It didn't matter. So,
one of the in my normal presentations, I always have a few slides that are just common throughout all the presentations. And one of them is the fact that I have two cars. One's a 2018 General Motors product with all the safety features, ADAS and, LiDAR and, all that stuff. And my other car is a 1968 Mustang. And the kind of the joke, the bottom line point that I try and bring home is if 100% of the electronics failed in my Mustang, 100%, I would only not be able to listen to the radio because that's the only electronic. There are electrical components in there, points and distributor and all that stuff, spark plugs. But there are no circuit boards in there except for this crappy little AM radio, which doesn't even sound good, right? So, but if any of the electronics failed in my modern car, I could steer off the road. I could I could back into something. The adaptive cruise control could fail, and I could rear end somebody. I mean, all these bad things could happen if it fails. So, two different eras, and so much has changed between those two eras. Yeah. Well, Bob, this has been great. Thank you so much for the last hour. Time has flown by, so I didn't mean to keep you so long, but thank you so much for being my guest today. I really appreciate it. For those of my audience who want to get a hold of Bob and learn more about what they do and he does, just look at the show notes. If you're watching this on YouTube, just look down where it says see more, and you'll see Bob's contact information there. And if you're listening to this on Apple Podcasts or Google Podcasts or Spotify or wherever you find this show, just look at the show notes and you'll be able to get more information on Circuit Technology and Bob Doetzer and the effort that he's making to train the industry. Bob, thanks again for being my guest. It's been great.
Thank you, Mike. I really appreciate it. It's been enjoyable. Always good to talk to you.
Same here. Thanks for listening or watching the Reliability Matters podcast. Be sure to subscribe to the podcast on your favorite podcast app, such as Apple Podcasts, Google Podcasts, Spotify, and so many more. Also, be sure to check out my other podcasts, including the Concept to Creation podcast, where I feature conversations with entrepreneurs within the electronic assembly space, and the Innovations in Technology podcast, where we discuss innovative products within our industry. All three shows are also available in video format. Check out the Reliability Matters or Concept to Creation or Innovations in Technology podcasts on YouTube. Just search the show's name and you can find all three shows. Or go to MikeConrad.com. That's Conrad with a K. All three shows also appear there. Again, thanks for being part of my podcast family. I appreciate you being here. Until next time, stay safe, stay healthy, and stay happy. And of course, keep doing it right. See you again soon.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.